I believe this to be the second to last. There will be some overlap from my 2.2 and 2.3 videos. I made all the other videos a couple of years ago when we were using a different textbook, so there will be some overlap. So if anything gets redundant, like I already got that, just skip over the video. Yeah. I just realized that right now. I'm like, I think I do a lot of this stuff in 2.3. Maybe it's an opportunity to see it twice in two different manners. So I just wrote up a couple things. 0 degrees is the same thing as 0 radians. You can always tell a radian. We don't write rad afterwards. It's implied. If we're talking about an angle and there's no degree symbol, it's in radians. We must make certain that we use degree symbols properly or don't use them when needed. 30 degrees is the same as pi over 6, 45 degrees is the same as pi over 4, 60 degrees is the same as pi over 3, and 90 degrees is the same thing as pi over 2 radians. And that's all from the work we did in 2.1. Everything will build upon itself. I'm telling you, 2.1, 2, 3, 2.1, 2, and 3. This is all the fundamental knowledge you're going to need to do everything else once the class gets much more challenging. Yeah, it's going to get more challenging. This is just a beginning memorization. There's a lot of it. Could you imagine trying to do algebra, but you don't have memorized, like counting 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10? You didn't know that, but you're going to try and do algebra? So that means you can't add and subtract. It means you can't multiply or divide. You can't find any square roots. It's the same idea in trig. If we don't know these basics at the beginning, these are not basic. They're tough, but they're going to become our basics. There's no way you're going to solve everything else. So please, I'm begging you, memorize, get this stuff down. Oh, how are we going to write all this stuff? I just want to make sure that this is hammered home. Actually, I don't need to write anything. Sine of 0 degrees is equal to 0, which means sine of 0 radians is equal to 0. I just took the degree symbol off. That's the one. 0 degrees, 0 radians, they're equal to each other. So cosine of 0 is also equal to 1. Well, now I'm just going to cheat. I'm just going to say, well, 30 degrees is the same thing as pi over 6. We could just change this to pi over 6. Therefore, sine of pi over 6 is equal to a half. Cosine of pi over 6 will be root 3 over 2. All we're doing is replacing the angle. It's the same gosh darn thing. Please know the difference between an angle and the ratio. Angle's inside the trig function. Ratio is what it's equal to. And I'm just going to keep doing the same thing. Remove the 45. Put in pi over 4. It's the same thing. Just two different languages. One speaking degrees, one speaking radians. And this is a big thing that I don't know whether I stress enough. Because we're going to move into radians. I know a lot of us struggle with going like, well, what's the difference? What are we doing? And it just looks like hieroglyphs. Yeah, I know. But that's true. All we did was change the angle. We still got the same values to pop out. So I want to make the table again. I want you to see the table being made so you can make your table as well. Because I will discuss much more all in radians. So 0, pi over 6, pi over 4, pi over 3, pi over 2. These are all of our common angles here. But we're still going to get that same pattern, that same structure out of this. And we'll put in tangent in a second. Where it's the square root of 0 over 2. The square root of 1, which is 1 over 2. The square root of 2, I don't know that 1 over 2. The square root of 3 over 2. Anybody know the square root of 4? Isn't that 2? So 2 divided by 2, isn't that 1? Oh, there's our pattern. And then we go back up and we go the other direction. I'm writing the same values, and I'm just, instead of going down, I'm moving up, right? 0, 1 half, or 2 over 2, or 3 over 2, 1. Now we're going 0, 1 half, or 2 over 2, or 3 over 2, 1. And then 0, and 1 over root 3, just dividing the numerators. Root 3 and undefined. There's our table again. Instead of writing in degrees, we wrote in radians. But 0 degrees is the same thing as 0. 30 degrees is the same thing as pi over 6. 45 degrees is the same as pi over 4. 60 degrees is the same thing as pi over 3. And 90 degrees is exactly the same freaking thing as pi over 2. So those values will remain the same. If I was to ask you, let's just do one quick thing. What's cosecant of pi over 6? What? I thought we were talking about sine and cosine. Well, you're like, whoa. What does cosecant go with? Doesn't cosecant of an angle, isn't that kind of go with sine of an angle? Isn't it just the reciprocal? Don't we just flip over our answer? That's all it is the reciprocal function. We just flip over our answer. So we'd look at this and go, well, what's sine of pi over 6? Sine of pi over 6 equals a half. So if sine of pi over 6 is equal to a half, what's cosecant of pi over 6 going to equal? It's just the reciprocal, 2 over 1. So there's no reason to memorize cosecant, secant, or cotangent. You just memorize sine and cosine. Everything else comes for free. I'm a broken record. Memorize everything with sine and cosine. It's going to make your life so much simpler. Not simple, but simpler through the class. Oh, all right. I'm going to stop beating that dead horse. We're going to move into some tougher stuff, which I think is going to be an overlap of 2.3, but you're going to get to see a lot more of it. So let's get it. Take it easy, y'all.